Next, let us consider how controlling takes place inside a switching system. How to make a call, how to end the call, how to establish connections between calling and the called person. So all those things we will discuss under this heading, control of switching systems. We know how switching systems have evolved from being manually controlled to being controlled by relays, and of course then electronically. So of course we know initially in the older days we used to control switching systems by using a manual operator, and then we gone for automatic using Stroger step-by-step systems which make use of relays, electromechanical components, and later we have gone for electronic components inside an automatic switching systems. So the change from the manual system to this Stroger step-by-step system, which is an automatic system, brought about a change from centralized to distributed control. So previously we used to have a centralized exchange office where all calls used to come to that particular office. But due to invention of automatic exchange, that is Stroger step-by-step system, which is an automatic system, we were able to make use of distributed control. So distributed control means depending upon the area we have distributed the control office. So that is how distributed control takes place with the help of invention of automatic exchanges. However, a system developed and offered more services. In coming days, we know development in systems observed, and a system is able to provide more number of services to its customers, and it became economic to perform particular functions using specialized equipment. So generally different operations will be performed by different equipments which are specially designed for performing certain operations. And using common control, we were able to control different equipments using different operations, and they used to provide connections as and when required. So when the connections is required, then only these equipments are being used depending upon the type of service the system supports. So later the development of digital computer technology. So later digital computer technology has evolved, and this enabled different functions to be performed by the same hardware by using different programs. So previously we used to make use of a specialized equipment for different operations, but now due to invention of digital computer technology, now the same hardware is able to perform different operations or different functions by using different programs. So thus switching systems entered the era of stored program control, SPC. We know what SPC, switching exchange, look like. Generally SPC exchange is controlled by electronic devices or semiconductor devices. So an SPC public exchange can offer a much wider range of services than electromechanical exchanges provide. So generally SPC public exchange provides a large different types of services to a customer than what electromechanical exchanges used to provide. Some of the services can be controlled by customers. Of course, the customer can also control what services he wants to have and also how to make use of those services by the SPC public exchange. Since the processor's stored data can be altered electronically inside a SPC public exchange, we will be having a connection store as well as we will be having some memory components. We will be having a processor inside this SPC public exchange. So we can alter the data that is stored inside this public exchange, that is SPC public exchange, electronically by the end user or by the customer. One example is optional call barring is a best example. If a customer don't want to receive a call from a particular number, then he can go for call barring service. Similarly, repeat last call. So whatever the call he has made previously, he can make call without dialing those numbers. So that is what repeat last call is. Similarly, reminder calls means call can be made with the help of reminder placed inside a telephone. Of course, if I am placing a reminder call, so those data will be stored inside this SPC Public Exchange. And also we know what call diversion is, and three-way calls. This is nothing but conference calls. So at a time, 3 or more number of persons can be talk to each other. So all those services are made possible with the help of invention of Stored Program Control Public Exchange, SPC exchange. So generally in the first generation of SPC system, so the controlling processors were large size computers. Generally inside this SPC exchange, we used to use a large size computers which are more expensive also. And also it is uneconomical to provide more than one computer for each switching system. Into a SPC exchange, we are not able to provide more number of computers, because if one computer fails, another computer must be able to take the load or must be able to perform the operation what was performing by the previous computer. That is what a standby is. So with a standby to provide service if a fault occurs. Generally in the early days, in the first generation SPC, we used to use a single large size computer, which is of course expensive also. Since it is expensive, we are not able to make use of another standby computer, and this resulted in the centralized control was reintroduced. So we know when automatic exchange came into effect from centralized to distributed control happened, but due to, of course, with the invention of SPC, due to expensive of large size computer, again from distributed we came back to centralized control. Subsequently, the cost of call processing was reduced. The cost of call processing includes the switching system cost, includes the computer's cost by the invention of microprocessors. So the cost of call processing was reduced by the invention of microprocessor. This enabled various tasks to be done from the central processor to small processor. Since previously we are using centralized control, it means we will be having a single computer or a processor which performs almost all operations. But now with the invention of microprocessors, we have gone back to distributed systems where different processors are used, small processors are used to perform different operations. Of course, all these small processors are connected to a central processor. Of course, these small processors are associated with different parts of the system. Different operations are performed by different parts, which results into a more distributed control system. So this results in an evolution away from fully centralized control to a more distributed form of control. So next, let us consider how a call processing functions takes place inside a switching system. So if I want to make a call from one user to another user through a particular local exchange, let us say we are having a local exchange. For this local exchange, so many number of subscribers are connected. One subscriber wants to make a call to another subscriber through this particular local exchange, So how call is being placed, how call is being connected, what are the operations that are performed, what are the sequence of operations that are performed, we will discuss under the heading call processing functions, how the call is being processed by the local exchange. We will discuss in more detail. So first let us deal with what are the sequence of operations that are involved in a call processing function. So similar basic processes must be performed by a switching system in any network, whether it is circuit switch or packet switch. If I am dealing with circuit switch network, it is nothing but space division network. If I am dealing with packet switch networks, it is nothing but time division networks. We know clear difference between space division network. In space division network, we need to have a circuit being connected from one user to another user over the entire duration, whereas that is not the case in time division network. So the data is being sent in terms of packets or in terms of frames, PCM frames. So we know how packet switch network operates. So generally, whatever may be the network it is, the basic operations that are involved or the basic sequence of operations that are performed by the switching network, whether it is space division network or time division network, remains the same. So let us consider in more detail how a simple telephone call being placed between two customers whose telephone lines are terminated on the same exchange. That means a particular local exchange, two customers are connected, and let us discuss how the switching takes place, how a call is being established between two end users or between two end customers. A sequence of operations takes place in which the calling and the called customer lines as well as the connections to them change. So we know calling and call customer lines are involved. So call customer line means from a local exchange we will be having a subscriber line to calling person as well as a subscriber line to called person. So what are the operations that takes place inside those subscriber lines as well as the connections that are involved to those persons from one state to another are described below. Let us deal with what are the different states or what are the different sequence of operations that are involved. So the first state that we are dealing with, or the first operation or first scenario that we are considering, is idle state. So initially the customer's handset is in the on hook condition and the line is said to be idle state, waiting for calls to be originated or received. So generally a customer handset will be in the on hook condition. So generally the customer has not holded his telephone. Initially it will be in on hook condition. So we call such state as idle state, and that particular customer handset is waiting for calls to be originated, whether customer can make a call or he can receive the call, and we call such state, that is idle state, as state 0. Meanwhile the exchange is also monitoring the state of the line, that means ready to detect a calling condition. So if a telephone is in on hook condition, the exchange is also continuously used to monitor what state, whether it is state 0 or other than this, and the exchange is ready to detect a calling condition. If this off hook becomes this on hook becomes off hook, once customer holds his handset, it becomes off hook. So in that case the exchange must be able to detect a calling condition. So the next state or the next operations, the next condition that we need to deal with is call request signal. Once the customer sends a signal to the exchange to request a call for a telephone, so this call request signal is sent by the customer once he holds the telephone. Once he holds the telephone, the call request signal will be sent to the exchange from the customer end. So let us deal with what happens with respect to a telephone call. So for a telephone call, this is done by lifting the handset. Just in order to send a call request signal, a subscriber should lift the handset. That is enough. And this causes a current to flow in the line, and that will be detected by the exchange. So the calling signal is also sometimes known as a seize signal. So whatever the call request signal, sometimes it is also called as calling signal, and we call this type of signal as a seize signal. Seize signal means the resource is utilized, or this resource is utilized or seized, since it obtains a resource from the exchange. Resource from the exchange means the telephone line or the subscriber line is being utilized for sending the call request signal, and that's why we call the signal as seize signal. And once the customer has sent the call request signal to exchange, next sort of operation is calling line identification. Calling line identification, basically the exchange should read this particular call request signal or seize signal. So with respect to calling line identification, the exchange must be able to detect the calling condition, and this identifies the line which originated call request signal. So the exchange must be able to detect which line is sending the call request signal, and generally the signal is associated with the customer's equipment number, EN. Generally equipment number is said as EN. So we know call request signal is sent from the customer side by holding his handset, and this call request, once this call request signal is received by the exchange must be able to see which customer has sent this particular call request signal. And of course this call request signal will be having equipment number also, we call it as EN. So because the exchange must be able to decide which customer is sending the call request signal, so the equipment number to directory number translation must be performed by the exchange in order to charge for the call. So generally the exchange, what it does is, from this call request signal it receives equipment number. From this equipment number it converts into directory number. So generally, as we know, all mobiles will be having IMEI number. Similarly, each telephone will be having its own equipment number. So all telephone lines are connected to exchange. So the exchange will be having some storage. In that storage, it will be having what are the different equipment numbers the exchange is connected, or what are the different telephones the exchange is connected. So the exchange converts equipment number to directory number. Directory number is nothing but a mobile number. For a mobile, as we know, we will be having a particular mobile number. Similarly, for a telephone, we will be having a particular telephone number. So that is what a directory number is. So from equipment number to directory number, translation should be taken place inside an exchange. Of course, this translation is required to perform charging for a telephone call. So we know we need to charge for telephone calls being made by the exchange. So those charging operations will be performed by the local exchange. So once the exchange has decided which customer is making a call and the exchange is ready to charge for the call. Next, let us deal with a next sequence of operation, that is determination of originating class of service. Anyhow, the exchange has decided which customer wants to make a call, but the exchange should know what are the class of service that are provided for that particular customer. So it determines what are the originating class of service. Originating means from which user the data is being, or the signal, call request signal is being originated. So what are the range of services available to the calling customer is determined by the local exchange. Of course, this must be determined before making a connection. Whether the end user is supported with, let us say the end user is supported with video call, or whether the end user is supported with only audio call. What are the services that are available or that are provided for that particular end user by the switching system should be decided or should be determined by the exchange. So before making a connection, call being set up. So in an SPC exchange, a customer's class of service data will be stored. As I said, an SPC exchange will be having what are the different equipment numbers. Not only that are connected, not only that, the SPC exchange also has data being stored. What are the different users that are connected and what are the class of service they are provided with inside a line store. So generally, as we have used connection store, speech store in case of switching systems or space switch and time switch, similarly an SPC exchange will be having its own line store. It stores data what the customer is associated with, and sometimes this line store is called class mark means class of, what are the class of service that are associated is also said as class mark. So many more different classes of service can be provided, and there are alterable, and they can be alterable electronically. So by the exchange, by the SPC exchange, class of service can be altered electronically. Some under the control of customers. Example, optional call barring. As we defined optional call barring, so that is also a type of service. That is also a type of class of service, and of course that is having that control is available with the end user or the customer. So the next sequence of operation is identification of calling party. That is what the exchange should decide. Once it has received calling request, once it has checked what are the class of service that are available with that particular user, next it has to identify which person is making the call. Identification of calling party. So with the originating class of service indicated or indicates a multi-party line. We know large number of subscribers are connected to an exchange, so it is necessary to ensure that the correct party is billed for the call. So the identification of calling party is required in order to make billing. Whether billing should be made for the calling party, not for others. So not to ensure that the correct party is being billed for the call, generally identification of calling party should be made by the exchange. So in case of manual exchange, generally a person or an operator used to identify who is calling by asking that particular caller. But in case of automatic exchange, customers on two-party lines can be distinguished by calling condition placing. Of course, automatic exchange will be able to see or should be able to decide who is calling party, and that calling party should be billed. So next, once the calling party is being decided, next connection to the calling party is made by the exchange. So the exchange now makes a connection to the calling party. Please note that now we have established a connection from calling party to the exchange. The next part is from the exchange, connection should be made to called party. So what we do is, next, once the connection has been established, we will deal with proceed to send signal. Proceed to send signal. Please note that the calling party, till now he has not entered the data, or he has not entered to whom he wants to make a call. Once he left his handset, a connection will be established to the exchange through a lot of operations are involved. After this, proceed to send signal is sent from the exchange to the calling party. So now the exchange sends a signal, that means dial tone, back to the caller to indicate that it is ready to receive the identity of the line termination, or identity of the identity of the called party, that is line termination, to which connection is to be made. Now the exchange is now waiting for this information, and we call this as state 1. So proceed to send signal is sent from the exchange to the calling party, asking for the data or asking for the address of the called party to whom the connection is to be made. So next, once the calling party, that means the person who is making the call, listen this dial tone, then he enters the address. He sends the address signal. So basically this address signal will be having the data of the called party to whom the call has to be made. So the caller now sends a signal to the exchange to instruct it to route the call to the required destination. Of course, the routing has to be made by the local exchange. So the caller now sends a signal to whom he wants to make a call. So in a telephone exchange, this is done by dialing or by sending tone pulses. So the calling person he can dial the phone number or the telephone number of the called party, or he can send tone pulses from a push button telephone. So by pressing those telephone numbers, the person who wants to make a call sends a address signal to the local exchange. So once the local exchange receives this address signal, the local exchange must do selection of outgoing line termination. So now the local exchange should determine the required outgoing line or the required outgoing line termination from the address information that it has received from the calling person. Since the caller dialed the directory number, since the calling person dialed the directory number of the called customer, in general this involves directory to EN translation. So directory to EN translation is being made inside a telephone exchange before the connection is made from the exchange to called person. Because this equipment number is available with this local exchange, equipment number to whom the call is should be made, so that equipment number is available with the telephone exchange. So the telephone exchange makes directory to EN translation. So next, determination of terminating class of service must be made. So before making connection, the exchange should determine what are the class of service that are available with the called line or that are available with the called customer. So let us consider an example. If a call is to a customer having a private branch exchange, let us consider if the call is must be made to a private branch exchange, the customer will make a group of lines and any of these may be used for the connection. We know with respect to a private branch exchange, there are a certain number of customers that are connected to private branch exchange. Similarly, from this private branch exchange, there are certain exchange lines that are coming to local exchange. Generally, the exchange lines are less in number, and now what we are doing is the called person is inside this private branch exchange. The called person is inside this private branch exchange. So in such case, the customer will have to group. Customer will be having a group of lines and any of these lines may be used for the connection. As I said, there exists there are so many customers are connected to private branch exchange. There exists a few number of exchange lines. Through any one of these exchange lines, the call can be placed for the called person or the called customer. So that is what the customer will have a group of lines, and using any of these lines, call can be made. So once that is what the exchange has determined what are the terminating class of service that are associated with. Next, it goes for testing call line termination. So before making call, the exchange should make sure that the line is connected or the end user, the called person is connected, or whether he is free or not. So the called line may be unavailable. Sometimes the called person may be not reachable or unavailable, either because it is busy, he may be involved in some other call, or it is out of service due to some problems, it may be out of service. Therefore, the exchange tests the state of the line before making connection. The exchange used to test the line before making connection. So once it has tested, the exchange receives status signal. So the status signal, sometimes called a call processing signal, is now sent back to inform the caller of the progress of the call. So generally the status signal is sent back to the calling person, so to inform the caller of the progress of the call, how the call is being progressed. So it is usually an audio frequency tone or a pre-recorded announcement. If the signal is busy tone, so please note that status signal is sent back to the calling person, whether saying whether the called person is free or not, whether he is available or not to receive the call. If the signal is busy tone or number unobtainable, that means number is unreachable, unobtainable tone, the caller places the handset. So the called person returns his handset from off hook to on hook, and the connection is released, and then it comes back to idle state, that is state 0 is resumed. Otherwise, if the called person is available, connection to called line is, that is connection is made to called line termination. Having discovered that the called line is reachable, obtainable and free, the exchange makes a connection to it. Exchange makes a connection to called person. So once connection has been established to called person from exchange, now the alerting signal is sent. So alerting called customer must be made. So once connection has been made, the called person must be alerted by ringing his telephone. The exchange sends a signal to the call line to alert the customer to receive the call. So in order to receive the call, the exchange now sends a signal to customer, that is called customer, alert signal. In a telephone exchange, this is done by sending ringing current to the line. At the same time, the ringing tone is sent back to the caller. So as a call progress signal, the calling person also receives the ringing tone. The exchange is now waiting for an answer. And we call this alert signal state as state 2. Once the receiver or the called person has received his telephone handset, now the exchange sends answer signal. So when the called customer answers by lifting the handset, the line is looped and current flows. This provides an answer signal. to the exchange, causing it to cease sending. So previously the exchange used to send cease signal to called person. Now that signal will be closed or ceased, and the alert signal is sent back to the called person. The exchange also removes ringtone from the calling line and thus provides an answer signal to the caller. So exchange informs the called person at the other end the handset is being held dead. So that is what answer signal is. Answer signal is sent to calling person. If the called customer does not answer, suppose the called person has not answered the telephone call, even though it is receiving ringing tone, the called person has not lifted his handset. In such case, the caller replaces the handset. The caller who is making the call replaces the handset, and this causes the exchange to release the connection to the calling and called line. So the caller's line is now again going to idle state, that is state 0. If the other person does not receive, this person lift his handset back to the telephone, and we call it as idle state, that is state 0. So next state is completion of the connection. So once he has observed the answer signal, the connection is being completed. So the receipt of the answer signal from the called customer causes the exchange to complete the connection between line terminations, or between calling person and the called person. So once the connection is been established, that is what the completion of the connection is. Line termination, the calling and the called customer. So once the connection is been established between calling and called customer, next state is conversation state. So now those persons can talk to each other. So connection has now been completed between the line of the two customers. Then they can converse for as long as they wish, and we call this as state 3. Call this as conversation state is called as state 3. Of course, during this conversation, the exchange will supervise the connection to detect the end of the call. So exchange must be able to detect the end of the call and to charge for it. So during that conversation, the exchange should make charging by the help of metering or by ticketing. So once the call has been closed, once any of the subscriber lift his handset back to telephone, in that case clear signal must be sent. When each customer replaces the handset, line current ceases and to provide a clear signal to the exchange. So the exchange receives the clear signal either from this end or from the other end. So whoever lift his handset back to the telephone, or whoever goes on hook either this side or this side, so clear signal will be sent to the particular exchange. So once the exchange receives the clear signal, it will release the connection. The exchange then clears down the connection between the calling and the called line termination. Thus the ideal state 0 is resumed. There are theoretically 4 ways of controlling release of the connection. So of course we are saying connection is being released. Of course theoretically there are 4 ways to release the connection, and they are: first way is release when the calling party clears. This particular calling party, if he goes on hook, then the release of connection should be made when the calling party clears. Similarly, release when the called party clears. When the called party clears, he goes on hook, clear signal will be sent to exchange and the exchange will release the connection. Similarly, when the first party clears, when I am dealing with conference call, when the first party, that is the person who is making the first call, when he goes on hook, clear will be done. That means release of connection will be done. Similarly, release when the last party clears. When the last party clears, it means at the last party means at last 2 persons will be in conversation. When the last party clears, then also release of connection will be taking place. Since it is normally the calling party who pays for the call, it is reasonable for the caller to decide how long the call should last. So generally the person who is making the call, who is originating the call request, that person will be billed and he must be able to decide for how long the call should last. Thus the connection is normally released when the calling party clears down. So generally, as you can see, when the calling party releases, the connection will be removed. In the above example, every time has proceeded normally. Of course, in the previous example, whatever we have discussed previously, a sequence of operations what we discussed. So there everything has proceeded normally, everything has gone normally. However, the system, that is the exchange, must be able to cope with abnormal situations also. The system must be able to cope with abnormal situation. Let us discuss what are the difficulties that are arising. The difficulties arising when one party clears but the other does not. So we are having calling party and the called party. If both are placing their telephone, or if both are going on hook, no problem. But if one of them does not place their telephone into, or if they do not place their handset into the telephone, we will arrive with different types of difficulties. Let us consider the first case. If the called customer replaces the handset, if the called person or called customer replaces the handset but the caller does not, this particular caller is not placing his handset to telephone, or he is not going on hook, then the called line is still held. The called line, this particular line from called person to telephone exchange, this line will be still held on, and the customer is unable to originate or receive further calls. This person is not able to make new calls, or this person is not able to receive another call during that time, as long as he holds his telephone or handset. And this is known as called subscriber held. This is known as called subscriber held, CSH condition, called subscriber held condition. If the caller replaces the handset, let us consider the caller, this person replaces the handset but the called customer does not. This called person is not placing his telephone to, or is not placing his handset to telephone, that is, he is not going on hook. So in such case, the connection is released on this side but not on this side. From exchange to called person, the connection still remains. The loop still present on the line, loop on the line looks to the exchange, and it is like a calling condition. The exchange assumes this person, called person, is still on some conversation. The exchange assumes, because he has not gone off on hook. He has not gone off on hook. A new connection will be made to it. Of course, a new connection will be made to it, but there will be no response to dial tone. So please note that since the called person has not gone on hook, a new connection will be made by the exchange. A new connection will be made to the called person, but there will be no response. The other side, there will be no response to dial tone, and this is called permanent loop condition, and sometimes we call this as permanent glow condition, PG, because it result in a lamp remaining on or glowing a light on a Stroger selector. So in case of Stroger exchange, a light used to turn on as long as this person is holding his telephone. The light will be glowing. That's why we sometimes we call it as permanent glow condition. So we are having two condition. One is SCH called subscriber held condition because of this person, that is calling person, and we are having another condition, that is PG condition, permanent glow condition, because of called customer keeping his telephone in his hand. So the PG condition is particularly harmful. So the PG condition is particularly harmful, and this condition results in congestion. And generally, if a large number arises, if large number of persons, customers are holding the telephone, in such case the exchange is connected to them and the exchange cannot make new calls, because the exchange will be having a threshold so that it can make a sufficient number of calls. Since if large number of customers, end users, called users are holding their telephone for long duration, so it results in congestion. And of course this may happen when earth faults occurs. When earth faults on lines occurs due to damage of telephone lines, so congestion may also results. In the older systems, PG and SCH conditions had to be removed manually through manual disconnection by a maintenance technician. So by making use of, with the help of maintenance technician, we should be able to remove PG and SCH conditions. But in modern systems, a timeout process is used if the condition persists for more than a particular certain period of time. The call will be turned off or the connection will be removed. Example, a few minutes for a connection, the connection is automatically released. So that is what is sequence of operations that are performed inside a telephone system, that is inside a telephone local exchange when making a call. Okay, thank you.